We're checking our answers. 43. Pause it, people who were gone. We already looked at this one. Okay, now we're back. 24, 38. Why are there funny, let me get the calculator out. Why are there funny over 60 and, oh, wrong one. Over 60 and over 3,600? What's this for? Oh, no.
Converted.
That's not good. Yeah, they converted because they gave you degrees, minutes, seconds, right? They gave you degrees, minutes, seconds. So you had to think about, let's see if it'll write while it's coming up. Always likes to get in my way. Okay. So if you have 8 minutes, remember, you take one, we don't have the minute on top. What do we want on top? The degree. Over 60 minutes, the minutes cancel. 8 over 60 is how many degrees? Now, there's a typo. That should be a plus. Then how do we convert 10 seconds? Do you remember? How many seconds are in 1 minute? 60. That's not all the way. What else do we have to do? We have to keep going, yeah, to get to degrees. 1 degree, 60 minutes. Aha! So 10 over 3,600. That's the conversion way, reminding us of what minutes and seconds are, which is good review. However, tomorrow, isn't there a calculator portion to the test? Just like last time, you're going to get the non-calculator portion. You're going to finish it, come turn it in, grab the calculator portion, come back, maybe we'll do a better job of you have A, get the A, you have B, get the B version. We'll figure out something. That was pretty rough last time. But, coming back, you pick up your calculator, you finish. If you're in your calculator, let me get rid of this nasty graph. If you're in your calculator, is there a way to do degrees, minutes, seconds? The problem with secant, right? 1 over secant, no, sorry, secant is 1 over who?
Wait, secant? Wait. Is it secant? Yes. Oh, what's secant?
Okay, it's secant. Cosine. So 1 over cosine. Now we should be in degree mode, right? Degree mode, because this is a degree. Let's go over. All right. What's the whole number that we have in this problem, guys? How many degrees did they tell us?
56.
56. Cool. We could have done the plus 8 over 60 plus 10 over 3,600, but is there another way? Do you guys see second apps, an angle menu with a degree mark? Second apps. Okay, maybe you don't see it yet, but you just saw it, so now you see if your calculator has it, which it does. There's an angle menu. Second apps. How many minutes did we have? Was it 8? 8. Look at that cool little angle menu. What else does he have? Minutes. Second apps. That's where I'm going. I'm labeling my little pieces. What was the last one? How many seconds? 10. Now, some of you are like, oh, this is easy. Go to second apps. That really is a little R. It's not a second. It's not a double quote. So guess what? That doesn't work. You could try doing 2, 2. It doesn't work. It doesn't work. Why? Because the calculator has a quotation mark somewhere.
Oh.
Where?
Alpha plus.
Alpha plus. For all those little messages that I guess you type. I don't know what's going on. But anyway, they have little quotes, right? So they decided not to make a whole nother feature. They said, we already have one. They were a little bit lazy.
You're in the wrong place.
Oh, that's okay. I can fix it. Did you guys get it where you need it to be, though? Oh my goodness. Okay, so alpha plus. 10 years later. All right. Woo! Did it make it? Yep. Done. Done. Okay. Coming back to homework. That was number 38. Moving on. Next one. 52. They decided to choose the side. No pencils, color pens. Otherwise, I think you're cheating. Woo! Okay, so take this side. What they do to get this one? Distribute, FOIL, difference of squares, right? They did the math. And then from the math, what were they able to do? Now, you could have cheated a little bit, I think, in your trig identity chart. I think there's one that says sine squared is 1 minus cosine squared. But you could have also taken the property 1 is sine squared plus cosine squared. They cancel sine squared. Check. QED.
Quit.
No. Anyway,
Silent. It's Ted.
could be Ted, and then it's like KED like the shoes. Okay, give me back.
Wed is equal to me.
Okay, dun, 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 54. 54. You had a few different options, but I think you still should have looked at the Pythagorean properties. You could have changed sine squared. There was a property we wrote down for that. You could have changed sine squared to 1 minus cosine squared. Or you could have changed cosine squared to 1 minus sine squared. Either one was okay. They decided to plug in for that one. I would have gone straight down. They're going across. Either way. Then you distribute the negative. You have 1 sine squared plus 1 sine squared is 2 sine squared. Check. Some of you guys might have started on this side. You could have plugged in for sine squared, 1 minus cosine squared. But it would have been a little tricky. It wouldn't have gone back as nicely. So maybe you tried that side, but it got a little tricky. So maybe you should start on that side instead. Guys, remember, this is just a quick introduction to an idea we're doing in Chapter 5. So that's not a huge part of the test tomorrow. There might be one. There might be one. There might be one. But this comes back more so in Chapter 5. So if there is one, there's only one, and it's probably a bonus. What? Shh.
Wait, can
Giving
you go
too
back?
much away.
Can you go?
Go back. 64. Final answer is for x, 30 root 3, and for r, 60. You guys had to solve the triangle. For x, tangent was the best option because you had opposite and you were missing adjacent. So then they plugged in and solved. Some of you might have gotten decimals, but that's because you were being lazy and not using the unit circle. Or maybe you were being smart and using your resources, but either way, you can check the decimal. R is 60, using the unit circle again. Number 70, once again using tangent. Once again using tangent to solve the right triangle. They use a decimal this time because 54 is not in the unit circle. 137.6 feet, and I think that's it for 4-3. All right, turn 4-4. 137.6 feet. 4-4. Oh my goodness, so many evens. Reference, done.
Is that it?
I think so. Were there any other ones?
No.
Oh, well, that's easy.
Wow.
Oh, actually, hold on, cancel.
Oh.
In your groups, did you guys find any odds from 4.3 that you need to see? We'll get people to the board. Ricky.
71
71.
on 4.4.
On 4.4?
Oh, we're doing 4.3 right
Here,
now.
hold on. I just need a blank space and I'll just write them down. Okay. 4.3, 4.4.
Ow.
Number 71.
Yes, please.
Okay, what else? Nathan.
55 on 3.
55 on 3. Anything else? Caleb.
Never mind.
You good?
No, I put it in mine
On 3. Okay. Anything else? Okay. No, you're good. It's good to know that there were more than one question. Was more than one question. Alright. Volunteer participation. Nathan, what do you want?
49.
49, it's yours. Come on up. Grab a marker from the front desk. Make sure it gets back in. Okay. Anybody else?
I'll be that president.
Okay, I can do them. I'm just trying to offer points for you guys. I don't need points. Okay, who wants points for at least giving me the question and showing me what you got, even if you didn't get all the way?
I don't understand.
I will
Oh,
force you to keep going. I'll work with it. Sam, what do you want? Okay, it's all yours.
darn
Yeah,
it.
because you were working on it. Huh? Is 79 really long to write? Why does no one like? I can write on the board for
Wait, 79, you use your calculator.
Or 71, sorry.
This is confusing.
I don't know what I did. I wrote down like the question and then I wrote down the answer.
Alright, 71's mine. Too bad. You guys, all you have to do is write the problem. Alright, maybe it's awful. Let's go see. How awful is it?
Pretty awful.
Pretty awful.
Almost as awful as Phil's singing.
Last 2 times I wrote the board.
You are so mean. No, 71 was 4-4, right?
Yes.
The rest of you guys, if you need a book, I have a few extras up here because we're going to be working on the review, right? If you need a book, come on up and grab one. If I were you, I'd open up to the review to get all ready for our work. You already have it written in your spiral. So that way you can be ready to practice. Oh, guys, it wouldn't have been hard to write. Would it?
What's the value in the specific? Like, how do you write it in the quadrant?
Okay, let's check it out. Oh my goodness, you guys are crazy.
Yeah, we are. Oh,
Hopefully in a good way, right?
come on, Nathan.
All good things.
Are there any good crazy?
Doesn't matter either one. Alright, you guys can check out the ones on the board. We'll look at them really quickly and make sure they look good. First, number 71 that no one wanted, which means we all need it, or else we should have. Okay, 71. Okay, 71. Use a trig identity to find the indicated value in the specified quadrant. Okay, I have tangent, I want secant. Technically there are a couple of different ways of doing this. But since they said use an identity question, what is an identity that has tangent and secant and numbers only?
Oh, I think I know the answer.
Oh, I did
What's-
it just the way they wanted it to.
An identity that has tangent and secant and numbers only. Pythagorean.
Sin squared.
Don't use sine though. We don't want that one. Yeah, 1 plus. Keep going, Austin. And Caleb. Tangent squared of theta equals who?
Secant squared theta.
What can I plug in? Now, hold on. Wait. You guys know the notation, right? If it's tangent squared, doesn't that mean tangent, who he is, squared?
Yeah.
Right? And if we want, we could go ahead and just make secant, like let u equal secant or something. If that helps, just to kind of get the secant out of there and be like, okay, I want the unknown, I want the variable. What can I plug in for tangent?
3 pounds.
So I have 1 plus 9 fourths equals somebody squared. Don't we need a common denominator? We end up with 13 fourths equals u squared. How do I
Square root.
square root? Now technically with the square root, don't we need a plus or minus? But wait. Here's where the quadrant comes in.
Oh.
For a particular quadrant, doesn't every trig function have a particular sign?
Yeah.
SIGN, plus or minus, positive or negative? So in the third quadrant, just imagine, it doesn't matter too much. Just make an arbitrary angle and say, okay, for this angle question, what sign should secant have? Ask yourself, secant comes from cosine. What sign does cosine have in the third quadrant? Yeah. Cosine's negative, so secant is negative. So what do I choose as my final answer for the third quadrant? U equals negative. Keep the negative, lose the positive. Only one is appropriate, and the negative one wins. We don't know what root 13 is, so forget that, but we know what root 4 is, and that's 2. Dun, 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 dun. Does that kind of make sense? Awesome.
I got that way.
I was saying that the only identity question as far as like using one of the formulas beyond, like, okay, for unit circle you need to know that secant is 1 over cosine. So all of those ones, and tangent is sine over cosine. So all of those ones are kind of like for the unit circle, etc. Or like SOHCAHTOA, CHOSHICAL for right triangles. So the only ones that are really extra are the Pythagoreans, right? And so for those Pythagoreans, the only place that's going to show up is in the one trig identity question that's probably there. So your choice. but the rest of them above, hopefully we know anyway. Does that make sense? Okay. All right, cool kids. We've answered homework questions except peeking at the ones on the board. Nice teeth. 55 is the question. Sine over cosine.
Nothing given.
Okay, this one's my turn. Yeah. No one else wants?
Okay.
Yeah.
We're gonna swim.
You can do it? Okay. Perfect. All right, as Cameron comes, I'm going to go back and mark points. You guys go ahead and start working on the review. I'm going to give you some particular things about the test tomorrow, what to study in just a little bit. So go ahead and start working on the review, and then we'll peek really quickly after I mark down points and make sure everything looks good. Okay, so I got Nathan up to the board.
Oh, we don't write directions.
And then Sam, you wrote the problem, right? Thanks, Sam. What are you doing, bud?
Getting his pencil.
Oh, that would be helpful. Okay, lesson learned, right?
How long was that?
A while.
Should have left it for the next class.
Oh, I pulled it out yesterday because I was gonna give it to you after school and it didn't work out.
Tuesday after break is over. Just to let you guys focus for the test tomorrow.
Thanks.
Alright, kiddos. As Cameron is finishing, remember, tomorrow test, what's due?
Test review, quest review.
Notes,
Homework.
homework spiral, up through,
Quest review.
including the review, right? Okay, just making sure we're on the same page. Notes are due in class, homework spiral, I guess technically by the end of the day. When are your corrections due? Tuesday after this. Once again, TA and I will try to have them ready for you at the end, but sadly, I think that's gonna be so you guys might need to get your corrections out of your spiral before you turn them in, that way you can work on them over break. I have no idea. Yeah, but that doesn't really make sense. It was a drive-through where they are used to the tapes coming out, so maybe they're used to being able to show that.
You should pay it to go to sit with a cup of water, 2 shots, espresso.
On this last one? What did we do last time? We did 1/2. I think we did 1/3.
She just 1/2.
Maybe 1/4.
1/2 sounds
1/10.
I like 1/2. Ricky, I think we should do 2 halves. 2 halves.
No.
It's bad. Oh, wait, don't.
I can see
No, Ricky did.
Oh.
I'm
Why are all
I'm still failing it.
So then we do
You with 100% credit back.
whoever responsible
With
is.
100% no, it's You are, Really, I don't know, it's funny though. I lost it.
Question.
I legit lost it. There it is.
Oh, yeah.
Okay, see how it is.
You have to look and say, okay. Whenever sign it off. Or you could just jump it down.
I didn't do anything. He was the one that hit you.
Yeah.
Writing that triangle is always the one
Basically, you touched me, which touched her.
I would have gotten like 36, but I got the picture of it. And these are all, yeah, I got the picture of it.
Alright, Nathan, the only thing that I would add is just showing that the cosines cancel, but otherwise it's good. And then for number 55,
My ethos.
okay, Cameron, technically, yeah, that does totally show that it's right in the sense that it works. However, if we were to do it, sticking completely to one side and not moving stuff to other sides, because yours does show that it does work. The nice thing is it shows that it's true. But if we were to stick to one side completely, I probably would have gone an alternate way. So let me just show you guys another way of thinking about it. But without covering chapter 5, I probably wouldn't be too particular at this point. I see multiplication and I see addition. I need the addition to become multiplication. So I'm going to get common denominators, which, to be honest, is a complicated step, and it's one that many would not think of doing. But if you get a common denominator, notice that now you have a sine times a cosine in the denominator. These two combine together. There's still addition up top, that's true. However, maybe there's something special about that addition. So actually, Cameron, I use the same identity you do, just in a different way. And sine squared plus cosine squared is 1. And then I think of, but wait a minute, isn't 1 over sine someone special? And isn't 1 over cosine someone special? And I can say, check.
Question.
Alright,
If it says change the angle, change the angle measured to degrees, minutes, and seconds, how far down do we go? If we're at
well, until you get as many, you're allowed to have a decimal in the seconds because you can't go any further. There's no other breakdown besides seconds. Does that make sense?
Yeah,
Go ahead and give me that example because I'm pretty sure people are not going to like that one.
13.
Is that on the review?
Yeah, 198.4 degrees.
We're trying to convert to degrees, minutes, seconds. Do you
Yeah.
guys remember what number I don't mind being a degree?
10. 60.
No, from this one.
Oh.
Who can I keep because he's fine the way he is?
100.
More than that.
0.4.
Maybe.
Can't I keep all of them?
No.
No.
Yes.
Well, because they're whole degrees, so I don't mind the whole degrees. Remember what minutes and seconds do? They take a whole degree and they break it down, right? So they're fractional degrees. What's the fractional degree? Just the 0.4. 0.4 is the problem. If it was just 198, it's already in degrees, minutes, seconds. It's 198 degrees, 0 minutes, 0 seconds. So steal the whole number, take the fractional one off to the side and say, uh-oh, I need to get to minutes. So what am I going to multiply by? Where do
60.
degrees go? On the bottom. 60 goes on the top because he's minutes, right? Then we multiply. To be honest, I think this multiplication would be a lot easier if we change 0.4 to a fraction. Oh, hey, 5 and 60 is 1 and 12. 2 and 12 is 24. The degrees cancel, that's minutes. I don't go any further because there are no more decimals. There's nothing else left this one happened to be able to be cut into degrees and minutes, and you could say, I suppose, 0 seconds. Or just not right seconds. You guys have the answer?
Yeah.
Alright, hints for tomorrow's test. But I'll let you guys just work to the end. Sound good? Do you still need to know the unit circle for tomorrow?
No.
Yes.
Yes! For what part? The non-calculator one, because I promise I'll put something in there with the unit circle. Okay, so you still have to study your unit circle, but hopefully we've already been studying, just need to polish it a little bit tonight. Let's see, important ideas. How about complement supplement? For radians or
Okay.
degrees. Why don't you open your notebooks and write down?
I have a question.
Oh, good idea.
I still don't get all that stuff. The changing all the things to the one side. I'm still not.
Okay, so good thing, someone, anyone, third time I've said it today.
It's a bonus.
Tomorrow,
It's only gonna be
if
a
it's
bonus.
there, it's gonna be a bonus, and it probably won't be a super complicated one. Because those are coming in chapter 5, where we can have a whole section, we can talk about ideas and do tons of examples.
Okay, so they're not coming back in chapter 4 at all? Alright.
Not in chapter 5.
Okay, but I want to get that bonus.
So study the examples. In the sense of,
Like the.
you either plug in right away, or you do some math right away.
Alright.
What do I mean? This one, Nathan plugged in right away. He made tangent sine over cosine. He could have tried 1 over cotangent, but nothing would have happened. But sine over cosine, it was awesome. This one, I guess we could plug in tangent plus cotangent, but that doesn't get me closer to cosecant times secant. So I did math first. I did a common denominator. And the one that was up there, the 1 minus cosine times 1 plus cosine, both of theta. That one is not really an identity that goes along with it. We never go back to opposites and adjacents, never go back to that, only to the identities. So we did math first. We multiplied them and said, okay. So those are the 2 ideas, math first or plug in first and see what happens.
Okay.
Okay, we talked about complement supplements. Knowing where angles fall in the unit circle, radians or degrees. Knowing that positive angles measure up counterclockwise, negative angles measure down. How to find coterminal angles, how to find reference angles. I already said unit circle, right?
Yeah.
How to be given a funny fraction, not a funny fraction, but a non-unit circle value fraction for one trig. Make a triangle out of it, solve the triangle, and solve for other trig. Ooh, wait a minute, we have an example in our notes. Do you guys want to turn there real quick? Beginning of section 4.4. I think it's 4.4, maybe 4.2. You're given, that's not really what is it? Here's 4.2. Aha! 4.3. First example. Something like that. Something like that. But that one I just showed you on 4.4, he's pretty good too. And then how to solve right triangles. How to solve right triangles. Meaning, figure out what you're given, figure out what you're missing. Figure out what you're given, figure out what you're missing. And then solve appropriately with tangent, sine, cosine, etc., etc., etc. See, for the most part, kiddos, we went through everything. Complements, supplements, reference angles, unit circles, right triangle problems.
So.
How to go from a value to a triangle to solve, or how to go from like a point to a triangle to solve. You got that? Yes. So degrees, minutes, seconds are a yes, but linear, angular speed, even area of a sector, don't worry about. We looked at it in notes so that we can kind of say like, oh, hey, we're getting ready for physics kind of thing. Remember pre-calculus is pre-everything math? However, I'm not gonna make you memorize those for tomorrow. Alright, kiddos, you still have like what, 7, 8 minutes? Let's get some review work done. Cool? Let's get some review work done.
This is 27.5.
I asked you to find the coach of 60. That means another way to rotate here besides 60.
The middle one?
I could subtract 300. Sorry, subtract 360 and get 103. I could also say, or I could go 360 and another 60 is equal to
Number one? Yeah. Well, wait, so when it's just three, what's your position?
plus different 360 or 360 times 1. You could find another one by doing another 360.
So that means it goes around one. Once, so it goes around the unit circle once the half. One.
What is
Now, what happens to 3?
Almost 4.
Yeah.
Yeah, that's one way to get there. Go this way, this way is harder.
16 over 4.
How it was like, minus 16.
Oh.
It's like I minus instead of 60.
So, and you know that this is 2.
Instead of 160, that means a radius.
1.
Which would be pretty.
I mean 1 and 2 and 3 and 3 fourths is like it's like right here.
Yeah.
Okay. And then what would be the
So, and then you just, what quadrant? What quadrant?
it's in quadrant 4.
And then how do you say the last part? Oh, it's in quadrant.
Is that it?
Oh, wait. 3. Oh, 3. But no, this is 1, 2, 3, and then 3 fourths is down here. But doesn't start right there. That wouldn't start. And then you know how to find the
Is that what it asks?
Yeah.
Determine one positive and
You're close to have.
what's even a coach? I don't know what a coach is.
Well, we wrote a definition. Yeah, I think it was like 4-1.
There is
Okay, there, I think angles that share a terminal side.
Yeah. So you see how 60, you try to find out how to get from this side all the way over here.
Oh.
You started going all the way around and figure out how to get
Was it a negative?
Yeah, there's one negative and one positive. And then the one positive you go all the way around and then keep going to the left. So one
So, it's in radians.
Greater than less. Which side is greater than? Greater than is C.
Did you guys figure out what 15 pi over 4 was? Okay, if it ends up being a 3/4 pi, we could tell by dividing we would get 3 and 3/4 pi. Wait, 3 and 3/4. Hold on. Careful. We have to go 1 pi, 2 pi, 3 pi, and 3/4 pi is down here. Now, you could ask yourself what other angle is down there, and maybe you would be able to know that this one is 7 pi over 4. So maybe just unit circle would help. Or you could also go negative pi over 4. But wait, pause, sit. You guys have way too much fun just going when you want. Down, 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 down. People that add or subtract 360. This is in radians, so you would add or subtract what? 2 pi. 2 pi, fine. Do it. Study for tomorrow, the after school, or during lunch.
Why does the back of the book say 23 pi over 4?
Because that works too.
That's another answer.
So why do you,
They just added 2 pi.
why do they go so big?
Because it's still a coterminal angle, so there's no point in
No,
not.
I know, but I'm saying, why do they have to go that big? Why can't they just go simple?
Because they originally added 2 pi.
I know, but why can't they do that? I know, but I'm saying, why don't they do that? Because it's easier.
It's basically how you're supposed to do it is add 2 pi and minus 2 pi.
Yeah, like that's the normal way. You got it.
Yeah.
Okay.